Welcome back, ladies and gentlemen. Mr. Cowan here to help you through Unit 3, Lesson 10, entitled Using Equations to Solve for Unknown Angles. And let's go ahead and use equations. Our goal today, use equations to determine missing angle measures. Now, for a moment, if I could ask you to please go ahead and work on the warm-up. Come on back when you're ready to review answers. Let's talk our way through this. What type of angle do angle DAB and angle BAC form together? That word, ladies and gents, as weird as it is called a straight angle. More on vocabulary review later. They also form supplementary angles as both X and Y added together make 180 degrees. And so if we take a look at number 2 where it says select all statements that must be true, if you start with 180 and subtract one of them, whether it's X or Y, it'll work. So choice A is correct. Choice B is not correct. You cannot subtract 180 from something smaller than 180 and get a positive angle. Now, interestingly enough, if the two together form 180 degrees and you multiply both sides by 2, you'd find that 2 x's and 2 y's added together will be equal to 360. So choice C is good. Choice D, while it is possible, is not the case. And choice E will not work either. How do you know these angles are supplementary? Because when they add up to form a straight angle, it's going to equal 180 degrees. Where in the diagram do you see this? Again, I kind of showed that already. But if we put the blue together with the red, they would make purple, thus forming a straight angle. Now, go ahead and pause the video if you need, rewind, watch it again. Otherwise, let's head on to some vocabulary. Let's talk through some vocabulary, shall we? All right, adjacent angles, ladies and gents, are any two angles that are formed right next to each other, as long as they share a vertex and one of the rays. So angle C and angle D are adjacent, angle A and angle B are adjacent. All right, what about a right angle? This one most of you know, any angle that measures to precisely 90 degrees. Now, if you cut up a right angle, you'd have an example of two angles that are complementary. Now, complementary angles are formed when two angles would add up together to make 90 degrees. Now, for the record, you can have two complementary angles that are not adjacent. If I still added angle E and angle F together, they probably, if I drew it well, would make 90 degrees. So while we are used to seeing adjacent complementary angles, I did want to point out angles do not have to be right next to each other with a shared vertex and a shared ray and be complementary. Straight angle, ladies and gents, we've already discussed. Any angle, as weird as it seems, that would make a perfectly straight line. Supplementary angles, for instance, angles G and H, are two angles that when added together would equal 180 degrees in total. Now again, if I may re-emphasize what I said before, two angles do not necessarily need to be adjacent to be supplementary. In fact, I could even rotate this guy. Angle I and angle J are still supplementary. Why? Because if you took out a protractor and you added up the measure of angle I and the measure of angle J, it's still going to equal 180 degrees. Last but not least, vertical angles are the result when two lines intersect And a vertical angle is an angle that is exactly opposite of each other. In fact, I always kind of look for the V. So for instance, angle K and angle M are vertical, but you know what? Angle N and angle P are also vertical. And vertical angles are always congruent, meaning their measures are exactly the same. So you could say the measure of angle N is precisely the same as the measure of angle P. All right, so that was a little review. If you need to, go back, watch it again. Meanwhile, for the rest of us, let's go onward to activity 1. I'm going to do activity 1. I'm going to do a couple of these and then you'll take over from there. First part of the directions, match each diagram to an equation that represents it. For each match, explain how you know that they are a match. Now, speaking of vertical angles, take a look at all these examples of equations. We're going to use each of those, I believe, once. I look at number 1, angle G and angle H are the result of two lines that intersect G and H exactly opposite of each other. And so angle G, ladies and gents, is the same as angle H. I'm going to go ahead and circle that or maybe even cross it off. And again, my explanation, they are vertical angles. Vertical angles are, maybe I should have written vertical angles are congruent. Congruent means same size, same shape. So I already have one equation. Onward for number 2, where I'm seeing that G and H together seem to add up to form a straight angle, and therefore I do believe that G plus H is equal to 180 is the optimum one, and that is, of course, the first equation. How do I know? I'll write supplementary angles add up to 180 degrees. That's the good vocabulary. All right, with that in mind, folks, go ahead and pause the video. Challenge yourself on numbers 3, 4, and 5 to match each of the remaining 3 equations to their appropriate diagram, and then go ahead and explain it. Pause, come on back when you are ready. All right, taking a look at these, folks. If I notice that G could be written up here as a vertical angle, that means if we were to add up all the pieces of that, G together with H together with 35, that would equal 180 degrees. Reason for that? You could say a combination of this. Vertical angles, and then angle G, H, and 35 degrees form a straight angle. Onward we go. This is interesting. We see another G here. Let me go ahead and zoom in a bit. Where G has another vertical angle up here. So if I were to add H and G and another H, together they form a right angle, and so they add up to 90 degrees. And so why not rewrite that as two H's, as single G equals 90? And the explanation again, ladies and gents, should mention something about vertical angles. We used the vertical angle of angle G. And then GH and another H form a right angle. Now, I hesitate to use the words complementary in general. Complementary angles mean two angles that add up to 90, and supplementary angles mean two angles that add up to 180, but not necessarily 3 angles. Nevertheless, it could work. You will not be surprised with the remainder. GH and 48, add those up. And for the record, you could have written h and 48, or you could have started with 48, then added g, then h. But in general, when it comes to algebra, we put the variable terms first, constant terms after that. And when you have multiple variables, we usually put the variable terms alphabetically. Now again, you're going to say something about forming a straight angle. Therefore, all those angles add up to 180 degrees. So pause the video, rewind if you need. Otherwise, on to activity 2, where we're going to continue this with even more challenging equations. We're going to use our equation skills, write an equation that represents a relationship between the angles in each figure. Then we're going to solve in order to determine that unknown angle measure. Now, note they may not be drawn to scale, so if one ends up being 72 degrees, but it looks smaller or larger than 70, that's okay. They understand that. They just don't want to give too much away. All right, allow me please to do number 1 and 2, and then I'll release you to do 3 and 4 on your own. Number 1, it sure looks like all these angles put together form up to make a straight angle, and therefore, if I see 1, 2, 3, it looks to be 4 x's plus another 34 degrees. If we put all that together equals 180. Now, that is the equation. That's the first part. Let's go ahead and solve it. Where first we're going to get rid of the 34. That has nothing to do with the x angle measures. 34 and a negative 34 make 0. Good. So the only thing remaining on the left side is 4 x's. And on the right side, we have 146. Now, I don't want to know what 4 x's are. I want to know what a single x is. So let's go ahead and split both sides into 4 parts. For our solution, split up 146. Anytime you want to divide into 4, folks, my suggestion, divide it into 2 and then divide it into 2 again. So for instance, 146, divide that into 2, that's going to be 73. 73, split that into 2 again, 36 and a half. Now you may write it in decimal, or you may write it as a mixed number, doesn't matter to me. All right, now this one I found fascinating. I don't see any vertical angles. I don't see any complementary angles. I don't see any supplementary angles, but it's interesting that if I look at all those angles together, they go completely around in a circle, which many of us realize is going to equal 360. So if I were to add y, 98, another y, 98, another y, another 98. Now you can take this one of 2 ways. You can either put the 3 y's together, 398s, not quite 300. Or you may rewrite that as, hey, Mr. Cowan, we got 3 groups of adding y and 98. Here would be 1, here would be another, and here would be a third. Now, I'm okay with you solving either way. You could subtract 294 from both sides. And then divide it into 3 groups. Or some of you might like this one better because if you immediately split it up into 3 groups, you'll find that each of those individual groups is going to be 120 degrees. Well, guess what? Take away 98, and you'll get the same answer, ladies and gents. Either way, you're going to get 22 degrees. So I'm okay with either equation. 3y, 3 groups of y plus 98 equals 360, or this very long one, or the condensed one where we combine like terms. And by the way, little disappearing ink here, if you were to distribute 3 sets of y, is 3y's. 3 sets of 98 is 294. Again, equivalent equations that lead to the same solution. All right, at this time, folks, rewind if you need, otherwise pause, complete these, come on back when you're ready. Couple different ways to do this problem. I found that when I looked at 148, that I noticed this angle was supplementary to it. So by subtracting 148 from 180, I found this missing piece to be 32 degrees. Now some of you are saying, why use that? Because now I have another relationship that forms a straight angle. And so when I look here, I see z plus z plus z, in addition to 48 and 32, together form 180 degrees. Here is my equation, where if I subtract 80 from both sides, we now are left with 3 z's equaling 100. And if we divide both sides by 3, that will leave us with 100 thirds is not a very nice decimal, ladies and gents. In this case, I might suggest leaving it as a mixed number. I do want to draw your attention to another way to think about it that actually involves vertical angles. So let me make this a little thicker. That might be a little too thick. Yeah, we'll give it a try. If you take a look at this 148 and you take a look at those angles, then 148 will be equivalent as a vertical angle to put all those together. Therefore, you could have said that 3 z's together with the 48 would equal 148. And there's another equation that, guess what, folks? If you went ahead and subtracted 48 from both sides, gee, this looks familiar, doesn't it? So that was an interesting other possibility. Most of us will go ahead and find that 32 degrees and then look at the straight angle relationship. But you could also use what we know about vertical angles to say, well, 3 z's and 48 is the same as what is vertical to it, and that's 148. Last but not least, problem number 4. You might not be surprised if it forms a right angle. Then what do we have here? We have 1, 2, 3, 4 v's, in addition to 15, 30, 45, and 60. Put all that together, it's equal to 90. There's our equation. Now let's go ahead and subtract 60 from both sides. That has nothing to do with the v's. Whoops, don't do that. There we go. That will leave us with 4 v's equaling 30, split up into 4 times, 4 groups. And again, if you ever split something up into 30, split it up into 4, split it up into half, there's 15 and 15. Split it up into half again, so that each of those would be 7.5. And you won't be surprised if Mr. Cowan comes up with another way. After all, what if we were to group these together? V plus 15, a second group of V plus 15, a third group of V plus 15, and a fourth group of V plus 15. So we have 4 groups of V plus 15, if all put together form a right angle and therefore make 90 degrees, where you might choose to immediately split it up into 4 parts. So a single V plus 15 is, well, let's see, split 90 into 45s, split 45 in half, 22 and a half. Mr. Cowan, is this really going to work out? Well, check it out. Subtract 15 from both sides. Man, I love mathematics, how there can be more than one answer, more than one route leading to the same solution. Pause, rewind if you need. Otherwise, on to the summary. What have we been talking about today? We are combining two different things that we have already learned, angle relationships with equations. And so we can use equations to solve angle relationships, find a missing angle, for instance, what's drawn in the picture. Now, in this particular case, they used a pair of what appears to be supplementary angle. Let me draw that a little nicer here. Where if we put x and 90 degrees together, 3x's plus 90, that also, because of the vertical angle relationship, is equal to 144. Then you go ahead and use your equation skills, subtract 90 from both sides. I sure wish they would have divided by 3 and shown that algebra step. In the end, we find our solution. So I'm not going to tell you this is an easy lesson. I won't say that at all. But it is something that I think is more challenging because it combines two things that we already know, angle relationships and how to solve equations, as well as what a solution means. Perhaps right now you can draw your own just reminders. What do vertical angles mean? Go ahead and draw an example. Don't draw the teachers, draw something that's helpful to you. Complementary angles is another relationship we talked about. When two angles together make a 90-degree right angle. So let's call this C and D. Supplementary generally are two angles that form a right angle. In any case, give yourself a little note here. And maybe over here I would write equals. Folks, from here, go ahead and head into your homework, which will be pages 260, 261, 1 through 6. Take care, do well, let's grow.